Hello friend, today we are going to discuss about rubber to metal bonded properties. In this session we are going to discuss about Chemlok adhesive system, functions of primer and cover coat, mechanism for rubber to metal bonding properties and surface preparation. What are the method of surface preparation like mechanical method and chemical method and adhesive selections and their applications and troubleshooting like cement to metal failure, cement to primer failure, rubber to cement failure, and rubber to rubber failure, like that. First is Chemlok adhesive system. In Chemlok adhesive system, we have two systems. First is primer and cover coat system, that is Chemlok 205, for example, plus Chemlok 220 or 6220 or Chemlok 6125 mean first is primer, that is Chemlok 205 or 207, and plus Chemlok adhesive like Chemlok 220 and Chemlok 620 or Chemlok 6125 or Chemlok 6100 series, like that. Means there is two layer, that is first is primer and second is cover coat layer, and primer is Chemlok 205 and 207 for in this example. In single coat Chemlok system, Chemlok 250, Chemlok 202 ABC, and Chemlok 607 and Chemlok 5151. These Chemlok are for single cover coat system. Now, functions of primer. Actually, primer provides heat and corrosion resistance and provide adhesion with metal surface, react with cover coat, and different in color like some primer are gray, some are the uh, in blue color like this. Next is function of cover coat. Uh, Cover coat are adhesive. Functions of cover coat are adhesive. That cover coat is react with unsaturation in polymer backbone, react with prime ingredients, and cross linkage with adhesive polymer. That example is Chemlok 220 or Chemlok 6125 and Chemlok 6100. Now next is the mechanism for bonding. What are the mechanism for rubber to metal bonding? In this, first we are using the metal, and after that applying the primer, and at primer above we applying the cover coat or adhesive, and next layer is for elastomer layer. Means first we need to prepare the metal surface, then we apply the primer, then after dryness of the primer, then apply the cover coat or adhesive, then after dryness of the adhesive or cover coat, then we apply for elastomer, or we are using in molding session or for elastomer application. In metal, these are the some failures like we can see the failure like cement to metal and like primer to adhesive, or some failure is like rubber to rubber, some failure is like uh, cover coat and between the primers, like that. Now next is the steps in rubber to metal bonding. First step is surface preparation, means we need to prepare the metal surface better. Next is adhesive selection. After metal surface preparation, we need to select the adhesive type of adhesive we are going to use, like what are the primer, what are the cover coat of chemical. Next is the adhesive application. What are the adhesive applications? And next is molding of products. How to we are going to produce the product? What are the molding conditions? And next is troubleshooting. That what are the failures in rubber to metal bonding properties? Next is surface preparation. Now, surface preparation are of two types. First is mechanical method. Second is chemical method. In mechanical method, short blasting. Grit blasting, sandblasting, grinding, and turning are the mechanical methods. And in chemical method, phosphating, anodizing, chromate conversion are the chemical methods. Surface preparation means mechanical method. Like first step is degreasing. Degreasing means remove the oil, grease and rust from the metal surface. Then grit blasting, like type of grit we can use, like aluminum for aluminum, aluminum grit for steel, and steel grits. And after that grit blasting, we can clean the surface of the metal surface. Next is surface preparation, that mechanical method. This is an example of the shot blasting. Grid type is mild steel and chill coastal. And or we can use sand also. For aluminum NSS, we can use aluminum oxide or sand also. Grid size is 16 to 40 mils, and we can prepare surface roughness approximate 15 to 35 microns. Now, blast media. Blast media is angular shape. Grid can be angular shape, cut sharp rights and belly ridges like this. These are the angular shape grid. Next is short. These are the grid in angular shape. It has the shorts in circular shape that produce dimple results like this. Means less surface area plus more potential for contamination. These are the for more potential for contamination. Now next is the properties or advantage of the mechanical method. First is the remove oxide build scale. Second is suitable for large scale, small lots, and no hydrogen embrittlement. Non-surface metal and mixed metal can also be used in mechanical method. Thermoplastic, thermoset, composites can be used in mechanical method. Now, disadvantage of mechanical method is poor layover time. Means after metal preparation, we can kept them maximum 4 hours. For mild steel and SS, aluminum maximum 30 minutes, means half hour, and brass and zinc is 2 hours only. Means maximum we can keep the metal after the mechanical method maximum 4 hours shelf life. After that, after 4 hours, metal surface preparation, uh, we can not apply the primer or secondary on that metal. We need to again metal treatment. We need to again done on the surface. Next is expensive and labor intensive is also. And next is wrap thin metals. Next surface preparation method is chemical method. That is example is phosphating method. In phosphatic method, first we need to do alkaline decreasing. In alkaline decreasing, we are applying the 10 to 15 minutes uh, in proprietary chemicals. Means alkaline decreasing is with the chemical. And after applying water lens, means wash the metal. Then again derusting. Derusting is by using the phosphoric acid and other acid can also be used. After derusting, again water is applied, means washing the metal, and again phosphating, then phosphating done. Phosphating temperature should be 80 to 85, and the coating layer of phosphating is 150 to 400 uh, milligram per feet square. Then again water is supplied, and after that passivation is done. Passivation is, that is humic acid passivation. That time is 30 to 45 seconds, and temperature is 70 to 80 degrees centigrade. After that drying is applied. Drying means oven drying or air drying is applied. Now, advantage of chemical method, that is better layover time. Means we can keep the metal after chemical treatment approximate 48 hours, minimum 24 hours. We can keep the metal 24 hours to 48 hours. More economical in large volume. If our storage is storage condition is very good, then we keep metals in 3 to 4 days also. Disadvantage: must have tight control on TTC. Waste disposal is difficult. Limited to a specific metal. Not economical in small lots. Now, next step is rubber to metal bonded with adhesive selection. In adhesive selection, we need to first select elastomer to be bonded, means elastomer type, like EPDM, like NVR, like natural rubber, like uh, PVC. Next is elastomer curing mechanism. What are the curing mechanisms? That is sulfur curing or peroxide curing. What are the curing conditions also? Next is molding methods. What are the molding conditions and molding parameters, time, temperature, like that. Curing conditions and substrate to be bonded and environmental working condition of the product also. Next is the Chemlok grades, like Chemlok primary grades is 205, 207, Chemlok 210, 219, Chemlok 220, 230 series, 250, 400, 600, 800. That is water based. Next is the some example of general purpose primer, that is Chemlok 205. That primer for all metal, nylon, FRP, and plastics. Good environmental resistance and operating temperature ranges minus 40 degrees centigrade to 120 degrees centigrade. That is low actually in comparison to Chemlok 207. Chemlok 207 is heat resistance primer. That is, heat resistance is minus 40 degrees centigrade to 188 degrees centigrade. Means we can apply the molding condition is 188 degrees centigrade. They are better perform. And better salt water resistance, excellent resistance to hot glycol plasticizer primer for all metal and different plastics. Now next is the EPCA grades. Some of the grades of Chemlok, that is Chemlok 220 now become 6220. Actually 6 is prefix that apply, that tells us that as the lead free Chemlok. Like Chemlok 6125, that's previously known as Chemlok 125, now becomes 6125. That is lead free Chemlok. Chemlok 225X series, like 6225, and Chemlok 252, that is 6100 series. Chemlok 252 HX series, that is 6108 Chemlok, like that. Now some Chemlok is general purpose Chemlok, that cover coat or adhesive, that is good Chemlok 220 and 6125 and 6220. The Chemlok 220 and 6220 is same, but 6 is applied for, that shows that the Chemlok 6220 is lead free Chemlok. And these Chemlok is general purpose Chemlok or adhesive or cover coat. This is good economic choice for the industrial application on bonds, natural rubber, styrene butadiene rubber, and nitrile butadiene rubber, and chloro rubbers, like acrylic rubbers. High sweep resistance and difficult to bond soft compound. Pre-cures if molding temperature is greater than 170. Means there is a molding temperature limitation in 6220 compound or adhesive or cover coat. Does not bond with sulfur donor cure system. Mean peroxide cure system and sulfur donor cure system. Sulfur donor cure system, they have less bonding, not bonding properly. 6220. Now, next is the Chemlok 6100 series or 6108. That is a general purpose adhesive, that is heat resistance adhesive or cover coat. It is a more versatile Chemlok adhesive that bonds various compound cure systems and elastomer hardness values. High previous resistance, high temperature resistance, good environmental resistance, good dynamic performance, bond low hardness compound also, bonds cured rubber to uncured rubbers, good sizing resistance, good heat resistance also. Means these are the very good Chemlok for heat resistance, temperature resistance, environmental resistance, like that. Chemlok for elastomer bonding, there is different Chemlok. It is 230 series, and another Chemlok is 230 series. Chemlok for elastomer bonding like 250 series, that is a special grade for zinc plated metal. Chemlok for elastomer bonding, that is specialties in Chemlok, that is grade for NDR and polyacrylic bonding, that is sealing application, that is Chemlok 202 ABC system. Now Chemlok application, adhesive applications. In Chemlog adhesive system application system, we need to first understand the adhesive mixing period to applications. Now, period to use, we need to first lift solid off bottom of the container which starter application or mixer. Means we can apply the starter or drum roller or pen shaker before use, and that RPM is 20 to 40 RPM, and we can use forward cup or zone cup for viscosity control or viscosity measurement. Now next is the typical mixing time, and container is 1 liter container. If we have, we can use hand stirrer, and duration is 10 minutes. And if we have container of 3.5 liter plus, we need to use hand stirrer, then air powered mixer. And 15 minutes we need to rotate that with the hand stirrer or air powered mixer. Uh, 20, if we have container of 20 liter, we need to use hand stirrer, then air powered mixer 15 to 30 minutes. And if we have 20 liters to 100 liters of container, then we need to use hand crank, then air driven agitators for 8 hour continuous mixing. Actual mix time varies depend on mixer type, product age, and shipment condition also. Now we need to use the type of the brush, and hand automatic dip spin, hand automatic spray, tumble spray, and others. Like this is the brush application. In brushing of smaller jobs and coating specific area, we need to apply the brush. It is inexpensive but least consistent due to operator variation. These avoid brush marks, puddle thick and thin application. Good transfer efficiency is greater than 80%. And choose right size brush for the job. Natural brushes suggested. Foam type are for water good type also. Keep brush dedicated to product. Maintain and dispose when worn out or when damaged. Next is the hand and automated spray line application. This is the spray line. Now we need to understand the distance of the spray and spray gun size. That is, what are the size, what are the nozzle size, like that. What are the pressure we need to apply. Type of the spray gun is high volume, low pressure. Nozzle diameter is 1 to 1.4 mm. Spray pressure is 30 to 60 psi, and distance between spray gun and substrate is 15 to 20 centimeter. Now, next is the typical automatic chain on edge, like this. The chain on edge method is used for application where adhesive application may be inner and outer diameter of the parts. An example of this application will be automatic bushing. Typical edge on line will be 100 to 20 feet long and 6 to 20 feet per minute conveyor line is. And this process is fast and eliminate the need to masking of the parts. Now, this is the typical automated chain on edge design. In this area, we are applying the loading and unloading area. This is the loading and unloading area. uh, the metal which are already mechanical or chemical treatment done their primer application now we can use by the typical automatic chain harness design. In this area we can load and load the metal treatment done parts, and then in this direction we can send it, that loaded metal to the oven area, and 5 to 10 minutes oven application done. Then again we send is the primer booth, means now metal surface is heated and now we are going to apply the primer. After primer application by spray gun or manual or automatic, then again we sended him to open area for drying the primer for 5 to 10 minutes. After drying of the primer, again we apply the second layer, that is adhesive layer, that is cover coat layer by the adhesive booth by spray gun or manual or automatic. Again we need to send him the open area for drying of the adhesive application. Now this application will be 5 to 10 minutes again. After drying the in oven, then again that coated parts sent to the unloading area. These are the typical automatic chain harness design. Now, these are also application. Next is the adhesive DFT requirements. Typical guideline for measurement DFT, that is dry film thickness, is we need to maintain the dry film thickness of primer 5 to 10 micron, and top coat or cover coat or adhesive 18 to 25. Total two coat system we need to maintain 25 to 30 micron. Single coat up to also 25 to 30 micron. Mean 5 to 10 for primer, and for 7 to like uh, 15 to 25 for the top coat and cover coats. In total 25 to 30 micron we need to maintain for two coats and single coats. Next is the adhesive application. DFT digital case, handheld or benched top units, three reduction method type DFT we can use, beta backscatter, magnetic induction and ED current. Now this is the example of the DFT gauges. Like this, we can use this surface for the metal surface or metal top surface, and in this area we need to show the readings of the uh, dry film thickness, like this. Next is the drying adhesive, means after the application of the primer or adhesive, how time duration is required. Typically 30 to 60 minutes for drying at uh, RT between coats and before molding, means we need to after primer application and cover coat application, 30 to 60 minutes also required for drying. That's uh, to cool down adhesive applications. Then we need to send that coated parts to molding area for molding application. Next is temperature and humidity in the plants, seasonal and change of the season. That is also important. Like our drying results in if uh, Chemlok or adhesive is not drying properly, then it results in blister, failure to subtract. That will be higher chances. And we need to dry that coats is temperature is 90 degree with airflow to speed up the drying system. Heat sources must be explosion proof. IR not recommended due to increased fire risk. Now next is the handling coated parts. We need to avoid gloves contact with the wet products and coated parts. If gloves are contaminated, we need to remove and use new ones. Avoid throwing parts upon another. Potential chipping to avoid. Avoid placing coated metals on floor also. Avoid totes, cardboards or other suitable materials. Keep coated parts away from the dust, direct sunlight and moisture also. Next is the molding conditions. Temperature must be more than 135 degrees centigrade. Avoid contamination of adhesive coated parts from oil, grease, mold release like. Maintain proper pressure and curing time during molding. And ensure fresh and build mixed compound is utilized and component equilibrate to RT before testing. Now next is the troubleshooting. In troubleshooting bond failure, following are the steps to troubleshooting. That's ASTM International failure modes and possible causes for these failures. That is, first is the cement to metal failure. In troubleshooting, first we are going to study cement to metal failure, then cement to plastic failure, then cohesive failure, then rubber to cement failure. Now, first is the troubleshooting bond failure, that is ASTM D429B, that is this type of failure like cement to metal failure. This one the metal parts, this one the primer. The failure between the primer and metal, that is cement to metal. This is metal, this is cement. These are cements. Now, these are the cohesive failure, means failure between the adhesive, failure between the primers is cohesive failure. And next is cement to primer. This one the primer, this was the cement. Now becoming this one the cement. This metal primer and failure between the primer and adhesive. That is cement to primer. Next is the rubber to cement failure. This one the metal primer adhesive. This one become now cement. The cement to rubber. This one the failure between this location, that is known as rubber to cement failure. Now, first is cement to metal failure. In two coat system, this is metal primer adhesive, and this one the rubber. Now, failure will happen cement to metal. This one the metal, this one the primer adhesive, this will become cement. The failure between the cement to metal means metal will be separated and primer will be separated. This failure is known as cement to metal. Almost 30% of bond failure occur in the industry. This like this. This is the metal part. This is the primer and cement parts. Cement to metal failures. Now, what are the conditions of cement to metal failure? It may be poor metal preparations, mean better chemical or mechanical cleaning requires. We need to check degreasing operation, means degreasing cell tank may be dirty, maybe chemicals are degraded like this. Second, we need to dry spray, means we need to pop webbing, means we need to open the spray guns. We need to check the spraying viscosity. We need to adjust adhesive viscosity. We need to use higher boiling dilute. We need to reduce atomizing pressure. We need to adjust proper position of spray gun like this. Next is the galvanic decay. Means we need to avoid dissimilar material after cleaning. Like iron grip we are using on aluminum parts. That's we need to avoid. Now, next is contamination of metal. Maybe metal after preparation got contaminated. Then cement to metal failure can happen. Next is solvent entrapment in adhesive film. Means we need to allow longer drying time between the adhesive coats. Means after primary we need to keep them properly dry. Then we need to apply the cover coats. Thick coat of primer. Maybe DFT diaphragm thickness of primer may be more, means more than 5 to 10 micron. That's maybe 25 to 30 micron or 40 micron like that. Cement to primer type failure. This failure is designed as CP failure, cement to primer. Now, metal primer becomes cement and cement to primer. Like this failure is CP failure. This is less than 5% failure occur in the industry. Failure between the primer and adhesive. This location. This failure is become the adhesive failure or failure is cement to primer failure. Maybe this failure causes of the failure may be contamination of the primer. Means primer after primer application or primer Chemlok got contaminated. Now next failure is cohesive failure. That is the failure between primer or adhesive layer means failure between in this section or failure between in this section also means between primer or between adhesive failure that is known as the cohesive failure means causes of the cohesive failure is primer or adhesive application or DFT meter is too thick means their dye film thickness is more thick means their dye film thickness is higher than 35 to 40 micron means like 50 to 60 micron they observe like that then this failure may be occur. For this we need to adjust the film thickness and reprocess the metal. Now next is the rubber to cement type failure means RC failure. This one the metal primer adhesive. This one the rubber. Failure between occur between the rubber to cement. This one rubber means like this rubber and this one the metal primer adhesive. This becomes cement. Means cement. This one this region and this one the rubber region. This failure become the rubber to cement failure. Now these are the 50% plus bond failure occur in the industries. Means these are the major failure occur in the industry. The designer has RC failure also. Failure occurs between the rubber and adhesives. Like this. This one the rubber is separated, adhesive is separated. RC failure. This can be causes of the RC failure is pre-cure of the rubbers pre-cure of the adhesive, maybe adhesive cures or rubber are the cured, low molding pressure, incorrect molding time, low DFT meter can also causes of RC failure. And next is the maybe rubber got bloomed or contaminated or rubber whiteness become whiteness, contamination of the coated parts or adhesive rubber are incompatible. Please like and subscribe the channel. Thank you very much.